Hello. All right, so we are, yes, that's right, we're in the logarithmic parent function. So wonderful. It is the inverse of the exponential function. For us, we're going to be dealing with base 2. Okay, so what do we know about inverse functions? Okay, so we know a lot. Yes. What do we know about them graphically? We know they reflect across y equals x, and we know that their x and y values, yes, they switch. So if for my exponential function with the base of 2, if my x's go from -2 to 2, that means my y values are going to go from -2 to 2. We're going to think a little bit backwards. So if I'm dealing with base 2, what is 2 to the -2 power? 1/4. What is 2 to the -1st power? 1/2. 2 to the 0 is 1. 2 to the 1st is 2, and 2 squared is 4. Now, what else did we see with exponential functions? We saw a horizontal asymptote. So here, we're going to have a vertical asymptote. And the reason why is this. When we're asked to evaluate an exponential function, we're asked to figure out, okay, for this, 2 to what power is 0? And we know that that's not possible. So that way we're going to have, or that's why, we're going to have a vertical asymptote at x equals 0. All right, graph with me, please, if you would. So 1/4, -2, due to the best of your ability. I know they're tiny. 2, 1, 4, 2, and this is what it looks like. Now, if we were to graph the exponential function, yes, it would definitely reflect across y equals x. Their x and y values switch. All of that still applies. Okay, so identifying h and k. H is 0, and k is 0. You can write it as a coordinate if you would like, but you don't have to. Okay, I'm fine either way. And then for the x-intercept, we see that it occurs at 1, 0. It's in our chart. We love that. So I'm going to put 1, 0. I like to do algebra, but I respect everyone's opinion. And then no, there isn't a y-intercept because that just, like we saw with the exponential, but reversed. It was on the x-axis. Now it's on the y. Domain. For the exponential function, the range was restricted by the horizontal asymptote. Here, we're going to see it switch. So we can say that x is greater than 0, or it goes from 0 non-inclusive to infinity. And the range is all real numbers. So yes, it makes sense that they should switch just from its inverse of the exponential. This one is increasing as our x's go from 0 to infinity. The y values increase. We are not decreasing. Is it 1 to 1? Yes. For every x, there's one and only one y, and for every y, there's one and only one corresponding x value. Rate of change varies. This is not a symmetrical graph, so nope. There isn't a minimum or maximum value because it goes off to infinity in both directions. Horizontal asymptote, no, that's what its inverse had. Logarithmic has a vertical at x equals 0 if there isn't a horizontal shift, which we don't have for the parent function. Excellent. Okay, so now let's move on a little bit. Just like we saw before, the capital B is the base. Okay, we saw that with exponential, so make sure that we don't think of that as a transformation. It's not, okay? For example 2, we're dealing with base 2. We can see that A is 2, which means we're going to have a vertical stretch. Vertical stretch. We can see that B is 1. Okay, thanks. B is 1, so that's not anything. H, or no transformation, pardon me, is -3, so that means we go 3 units left. And K is 1, so we're going to go 1 unit up. Setting up our transformation chart, B is 1, so that doesn't affect us, so it's just x minus 3. And then we have a is 2, so 2y plus 1. Now remember that y values go from -2 to 2. We work a little bit backwards. So -2, -1, 0, 1, and 2. It's always based off the base, which is 2. So 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. Let me make sure I don't need to get my charger. Maybe I do. Let me see. Okay. So to you, I never left, but I went and got my charger. Okay, so here we go. Now I won't get completely cut off from you. If we plug in 1/4 in for x, 1/4 minus 3 is going to give us 2 and 3/4 negative. If I plug in a half, we get negative, maybe if my pen would write, there we go, 2.5. If we plug in 1, we get -2, 2, we get -1, and then 4, we get 1. Now, plugging in -2 for y, we get -4 plus 1 is -3. Plug in -1, -2 plus 1 is -1, 0 is 1, 1 is 3, and then 2 is 5. Now remember, looking back at the parent function, we have a vertical asymptote at x equals 0, which means the only way for it to shift would be a horizontal shift, or h. So, exponential function, we saw that the horizontal asymptote was affected by the k value. Here, it's going to be affected by the h value. So we're going to have a horizontal asymptote at -3. Oh, what? Vertical. Hello. At -3. Sorry, guys. Losing my marbles. And then we'll graph. So -2 and 3/4, -3. Again, do the best that you can to get as accurate as possible. I understand it's not the easiest. Excellent. And there it is. Okay, so HK, remember you can write it as H equals K equals, or you're more than welcome to write it as a coordinate. It's fine by me, but know that it's not a point. Just tells us where we're shifting. There is an x-intercept, but it's not in our chart. So we get to solve. That's so exciting. Okay, so we're going to plug 0 in for y. So 0 is equal to 2 times the log base 2 of x plus 3 plus 1. I'm going to subtract 1, which equals 2 log base 2 of x plus 3. Divide by 2. So we get the log base 2 of x plus 3 is equal to -1/2. If you have a logarithm on one side, but not the other, your only option is to rewrite exponentially. So base is 2, exponent is a -1/2 is equal to x plus 3. Here, there's a couple things going on. We're going to have to apply the negative exponent. So that means we have 1 over 2 to the 1/2. We're then going to have to use our rational exponents and rewrite it as 1 over the square root of 2, which we can't have. So we're going to multiply it by rad 2 over 2 to rationalize. So x plus 3 is equal to rad 2 over 2. Ah, so good. And then we're going to subtract 3. This was amazing. You are more than welcome to leave it like that. If you would like to get common denominators, have at it. For me, I'm just going to leave it as is, but write it as a coordinate. Sweet. Okay, y-intercept. Oh, it looks to me as if it's at 4, but my graph isn't 100% accurate because of the decimals, and we definitely had to graph to the best of our ability. So we need to not assume that our graph is accurate. We need to actually solve. So y equals 2 log base 2 of 0 plus 3 plus 1. Well, in this case, without a calculator, I don't actually know what the log base 2 of 3 is. I don't know 2 to what power is 3 off the top of my head. And I don't need to approximate because that's not what it was asking me for. It just asked me to find it. So I'm going to write this as a coordinate to show I know how to find it, but I'm not a human calculator. Beautiful. Okay, domain is restricted by the vertical asymptote. So x is greater than, in this case, -3. Or we can say -3 non-inclusive to infinity. The range is all real numbers, the opposite of its inverse, right? This one is also increasing. So we're going to say it's increasing from -3 to infinity, not decreasing. Yes, it is 1 to 1. Rate of change varies. It is not a symmetrical graph. There aren't minimum or maximum values. We don't have a horizontal asymptote. It's inverse exponential function to do. And the vertical asymptote is at x equals -3. Sweet. That was fast. If you need to rewind, please, please, please do. But that is example number 2. And last but certainly not least, we're going to example number 3 where, yep, you guessed it, there is a p-value. P-value. So I'm going to say -3 times the log base 2 of factor out that b-value, so 2 times the quantity of x minus 2 minus 1. And I'm going to list everything out. So a is equal to -1 times 3. Why do I do it like that? Because there are 2 different transformations I need to list out. One is a vertical reflection. One is a vertical stretch. And it's important that we list them both. So if it helps you to write them out like that, I highly recommend it. B is 2. Now in the transformation chart, we take the reciprocal. So we're going to say that this is a horizontal compression. Compression. H is 2. So we go 2 units to the right. And K is -1. That is super ugly, sorry. So we go 1 unit down. All right, writing our transformation chart. B affects x in its reciprocal. So 1/2 x plus 2. And then we get -3 affects the y, so -3y minus 1. Our base is 2, so remembering that this is the inverse of the exponential function. Our y's go from -2 to 2, so I'm in essence working backwards. -2 to the negative, what? 2 to the -2 power is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. Okay, here we go. 1/4 times 1/2 is 1/8 plus 2, so we get 2 and 1/8. If I plug in 1/2, I get 2 and 1/4. If I plug in 1, I get 2 and 1/2. Plug in 2. 2 times 1/2 is 1 plus 2 is 3. 4 times 1/2 is 2 plus 2 is 4. All right. Whew, decimals. Gotta love them when we graph. If we plug in -2 for y, we get 6 minus 1 is 5. Plug in -1, we get 3 minus 1 is 2. Plug in 0, -1. Plug in 1, -4. Almost done. Plug in 2, -7. All right. Now, don't forget, there's a very important characteristic, which is the vertical asymptote based off the h. Actually, I have a lot of arrows. Let's just do a star. So at x equals 2, we have a vertical asymptote. And let's go ahead and graph. Again, please do the best of your ability. So 2 and 1/8, 5. 1, 2, 3, 4, 5. 2 1/4, 2. 2 1/2, -1. 3, -4. 1, 2, 3, 4. And then 4, 5, 6, 7. Yikes. Definitely intersects my asymptote, but with all the characteristics right now, if yours does that, it's totally understandable. Try not to, but sometimes it happens because 2 and 1/8 is really close to 3, as it should be. Okay, we're getting really, really close to the asymptote, but not there. All right, h and k. So h is 2, and k is -1. There is an x-intercept. Oh, but I don't know what it is. So we get to solve. Okay, so for the x-intercept, we're going to plug in 0 for y. So 0 is equal to -3 times the log base 2 of 2x minus 4 minus 1. You're more than welcome to use the factored out form or non. You're solving the exact same equation. It doesn't matter. So I'm going to add 1. It equals to -3 times the log base 2 of 2x minus 4 divided by -3. So we have the log base 2 of 2x minus 4 is equal to negative 1/3. Again, I have a logarithm on one side, but not the other. So the only thing we can do is rewrite it exponentially. So 2 to the negative 1/3 power is equal to 2x, I don't need parentheses, sorry about that, is equal to 2x minus 4. Oh, negative exponents, how we love you. So I'm going to take the reciprocal of the base, not the exponent. So it's 1 over 2 to the 1/3, which then becomes, it is a rational exponent, so it's 1 over the cube root of 2. Now, if I have 1, 2, but my index is 3, that means in order to rationalize, I'm going to need 2 more. So the cube root of technically 4. So we get 2x minus 4 is equal to the cube root of 4 all over 2. Don't you just love math? I know you do. I'm going to add 4. So 2x is equal to 4 plus the cube root of 4. Oh, that doesn't look like an index. There we go. All over 2. And then we need to divide by 2. But let's be honest. On the right-hand side of our equal sign, we got a lot going on. So let's just multiply by the reciprocal. It'll make things a little bit easier for us to distinguish and see, a little less messy. So x is equal to 2 plus the cube root of 4 all over 4. Now that is beauty. Get common denominators or don't, it doesn't matter. I'm going to leave it as is and write it as a coordinate. So 2 plus the cube root of 4 all over 4 comma 0. And that is ugly. I know some of you are like, it's fine. And that looks worse. Okay, so is there a y-intercept? No, because our vertical asymptote is at x equals 2. We are on the right-hand side. We will never intersect the y-intercept. Please do not solve. The domain is x being greater than 2, or 2 to infinity, non-inclusive. Yes, the range is all real numbers, or negative infinity to positive. Now, for increasing and decreasing, as x goes from 2 to infinity, remember you always use the domain. Good, our y values are decreasing. We have that reflection, so it's no surprise that that's going to switch from the parent function. It is 1 to 1. The rate of change varies. There isn't an axis of symmetry because it is not symmetrical. There isn't a minimum, nor is there a maximum value. There isn't a horizontal asymptote because this is not an exponential function, but because of, because of our h value, we know that we have a vertical asymptote at x equals 2. Well done. Hopefully you stuck with me on that one. I will see you later.